parallel lines and transversals. After watching this video, I will be able to apply theorems to determine the relationships between specific angles. So after we have parallel lines cut by a transversal like we saw in our previous video, we're going to have special angle relationships. And one of those angle relationships is called corresponding angles. So for corresponding angles, I'm going to have pair of parallel lines cut by a transversal. And if I have a angle measurement on the top left, then on the middle left, this is going to be a corresponding angle. And think about it like taking that first parallel line and cutting this in half. If I were to take the top half and put it right on top of the bottom half, they're going to correspond. The angles are going to land completely on top of each other. And that means that the angles are going to be congruent. So in the diagram that we have various angles. And because we have the corresponding angles theorem, then angle 1 is going to be the same. It's going to correspond with angle 3. Angle 8 is going to correspond with angle 6. Angle 2 is going to correspond with angle 4. And angle 7 is going to correspond with angle 5. Those would be corresponding angles given a pair of parallel lines cut by a transversal. We're also going to have 3 more theorems when we have parallel lines cut by a transversal. We're going to have alternate interior angles. So alternate, think opposite sides. Interior, think about the inside of your parallel lines. So alternate interior angles, angle 1 and angle 3 are alternate interior. And angle 4 and angle 2 are alternate interior. And this means that they're going to also have the same measurement. So they're going to be congruent. So angle 2 and 4 are going to have the same measurement. Angle 1 and 3 are going to have the same measurements. We also have consecutive interior. And I like to think about it like same side interior. So same side of the transversal, interior meaning inside the parallel lines. So 1 and 2 are same side interior because they're on the same side of the transversal inside the parallel lines. And then angle 4 and 3 are same side interior. Now these are not congruent to each other but are supplementary, meaning that 1 and 2 have to add up to equal 180 degrees, and then 4 and 3 have to add up to equal 180 degrees. So whatever the measurement of angle 4 is and whatever the measurement of angle 3 is, I know they have to add up and equal 180 because of the same side interior. Then I have alternate exterior angles. And this means opposite sides of the transversals, but outside the parallel lines, exterior. So 5 and 7 are alternate exterior. And then 8 and 6 are alternate exterior. And these two angles, they have to be congruent to each other or they'll have the same degree measurements. We also have a special relationship when we have perpendicular lines, a perpendicular line, and then a pair of parallel lines. So basically, if we are told that, hey, these two lines are parallel, so line A, B are parallel, and we are told that line T is perpendicular to one of the lines, so let's say line T is perpendicular to line A, then that means that it automatically has to be perpendicular to line B. So if we're told, hey, the two lines, whatever is in red is true, we can just assume that the line in green is also perpendicular because of the perpendicular transversal theorem. The good news is we can solve for this without even knowing the perpendicular transversal theorem, because we can use all the other theorems we just learned to find out that, hey, they're all going to equal the same angle measurements anyway. Okay, so we learned a lot of theorems and it might seem a little confusing, so you're definitely going to need to watch this video again. But we can use the theorems to kind of solve for all the angle measurements inside of parallel lines. So I have line L and M, they're parallel to each other. And then I have line K, which is the transversal. So if I'm told that one of the angles is 140 degrees and I need to find all the angle measurements, I can do that. So one, I can identify, hey, because this is the angle I am missing, I am given, then I have the other angle measurements, alternate exterior, because they're outside the parallel lines, alternate sides of the transversal, so it also has to be 140 degrees. Then I can actually solve or use my vertical angles theorem or corresponding theorem to say, well, this angle right here is vertical angles with the 140 that I just solved. So this also has to be 140 degrees. And this angle right here is also corresponding to the original angle up on top. So these two are actually corresponding. So that also has to be 140 degrees. And then again, because of vertical angles, I can say that the angle here is 140 degrees because it's vertical with the original, and it's also corresponding angles with the bottom left. So because of vertical angles or corresponding, I already solved 4 of the 8 angles. Now I can use the same side interior idea. Same side interior said that if you have 2 angles on the same side inside the parallel lines, then they have to be supplementary. They have to add up to 180. So 140 plus 40 would give me 180. So this angle in green has to be 40 degrees. And then because of alternate interior, I know that this other angle is also 40 degrees. And then because of either vertical or corresponding, we can say that the outside angle is 40 degrees because it's corresponding with this angle. And it's also vertical to this angle. We can also say that this last angle that we're missing is 40 degrees because it's corresponding with this angle, and it's also vertical to each other. So now I have all the angle measurements of the angles formed by the parallel lines.